Obviously, we've discussed this. There's no calculator. It's just going to be fine. Everything falls on triangles. Everything's good. Amplitude. Period. For sine and cosine, how do you find the amplitude in the period? What was the generic form for sine and cosine with h's and k's? 2 pi over b. So y amplitude a sine b. Yeah, and then the period is pi over b, the absolute value of that. So again, what we're looking at here for sine and cosine, they use the same generic formula for the graphs. And if you guys go back to what you guys did with your graphing, you're really good at this. It's not a lot of there's not a lot of craziness here. The biggest mistake that anybody made when it came to graphing is that you did all of your points correctly, but you accidentally went the wrong direction because you didn't see the a value being negative. You can still break everything apart into all the different quadrants of your fractional amounts. You're really good at that. Most of you guys did really well. You just made a bonehead move going the wrong direction. Yes, sir? I'm going to talk about that. Tangent's kind of like off on its own a little bit, so I wanted to talk about the sine cosine real quick. Remember, your amplitude is always the absolute value of a. What's that? Yeah.
Well, I mean,
I'm just starting. And your period for sine and cosine is always going to be 2 pi over the absolute value of b. Now, there was one trick every once in a while that you saw. Sometimes the b value was hidden within the parentheses, which means you had to factor it out. That was one trick that did happen from time to time. Other than that, your h and k, your h goes which direction? Left and right. K goes vertical. Thank you very much. So let's just take a quick look at a sine or a cosine graph and just see what we remember. Nope, I had to open it.
H is always like the opposite.
Yeah, h's are always opposite. That's kind of like the standard thing with that. Excuse me. Yeah, I'm going to do one sine or a cosine, then I'll do a tangent to kind of remind us how we do all this. Is there any shifts? Oh, there's no shifts in this section. I forgot.
Tangent, you have to draw a whole graph and make stupid little.
All right. Real basic setup here. We'll say we have y equals -2 minus sine times quantity x minus pi. And whenever we graph these types of problems, we always graph the parent function first, and then shifted at the h and the k. Now, one of the things, if you recall, that they like to do with you is they move that k value around just because they're jerks. Another k. Now, what is my value of a? -1. Good. So my value of a is -1. What's b?
1.
B is 1. H? Is it pi or negative pi? Pi. Very good. And k? -2. So that means every one of my points is going to move to the right pi and down 2. So we start this out. Hey, did you see the email about the whole part? Yeah.
I responded to that.
Yeah, because I'd rather not let them just flash.
I'd rather just use half our class or one class period there.
Much easier. So we start. Oh, wait, what's your amplitude?
Just 2. No, negative.
Amplitude is +1. Your period is what?
2 pi.
2 pi, very good. So when we start these out, I know my period is at 2 pi. I'm going to leave a little bit of space to the right because I know I'm going to have to shift it pi in the end anyway. So if my period is at 2 pi, again, I break it in half, and I go halfway here. Sine, where does sine always start? 0. Sine always starts at 0, then it goes to the a value. our A value is -1. So sine starts at 0, goes to -1, 0, +1, and 0. And there's my parent function. Now, to each of those points, all I have to do is move them over pi and down 2. Which means I just have to create another set of ordered pairs here, and at 3 pi, I have 5 pi over 2. What is this? Not 5 pi over 2. 2 pi. Oh, that's supposed to be at 5 pi over 2 here. And then this one was at, what am I forgetting which point.
All you gotta do.
That's all you gotta do.
That's all.
That's the only way. Oh, yeah.
Just everything.
3 pi and 2 pi here. 2 pi to 3. Yeah, okay. So this one goes to the right pi and then down 2.
Which one?
First one.
Oh, yeah.
Right pi. Down 2. Oh, I stretched this out. Fair, didn't I? Back up. Up. And whatever.
Close enough.
Close enough. It's close enough for government work. All right. Just squint. Stand on one foot. It looks fine. All right. What's different between sine and cosine graphs and tangent graphs?
The periods.
Periods are different, and what else?
Yep.
You have the asymptotes. Very good. So when I'm looking at a tangent, same idea. Y equals a tangent b x minus h plus k. When I set that one up again, the only difference here is when you're trying to find your period with tangent, it's pi over the absolute value of b. The asymptotes will be at half of whatever the period is. All right, that was kind of like the shortcut. The A value wasn't so much the amplitude, but it told you where that point was changing direction. If the A value is positive, is tangent going down and right or up and right? Up and right. So let's get a real fast tangent graph in here.
The amplitude is still asking.
It's not really called the amplitude. It's the A values where that halfway point between 0 and the asymptote, where that point changes. That's what it is. It's not considered the amplitude, but it's just an A value. Because there's no, amplitude, remember, is the maximum height. There's no maximum height value or low value on a tangent graph because it's vertical.
But it's A still finds that.
Yeah, it finds that point of inflection, we'll call that. I think it's exactly what it's called. So again, I start the same thing. A is -1, B is 1, H is negative pi over 2, and K is 2. B is 1, so my period is pi. When I graph out a tangent, again, always goes to the origin, the parent function does. If my period is pi, my asymptotes are at what and what? Very good. And this would be at pi over 4 and negative pi over 4. Remember, these 2 points after between 0 and the asymptotes are always halfway between. Always, always. So if your asymptotes are placed at pi, you'd be at pi over 2. They're at 6 pi, they'd be at 3 pi, and so on and so forth. Okay. That A value, that's where that point of inflection where things are going to change direction. It was at, A was -1. Since A is -1, which direction is this one moving? Down and to the right. So that means at negative pi over 4, it's at positive 1, 0, 0, and then here. Now the new graph is going to shift everything to the left, pi over 2. Again, the easiest thing to do first when you're working with the tangent graphs is to move your asymptotes first. So if I have an asymptote on the right at pi over 2, I'm moving it left pi over 2, where does it go? It's 0. If I'm starting at pi over 2, I'm moving it left negative. So I'll be at 0 now. This one, the negative pi over 2 now goes to negative pi, very good. And then instead of being at halfway point between here and here is at negative pi over 2. And then my two other points would then be, well, negative pi over 4 and then negative 3 pi over 4. The k value was 2, so everything's got to move up 2. So instead of being at 0, 0, I moved it left pi over 2 and up 2. Left 2. And there's my new graph. Tangent graphs, they're relatively simple. You just might get lost in all the dotted lines, especially if your shifts are very close within the yeah. If you'd like, that's fine. Crayons are okay, but they tend to be a little bit tougher to make very, they're a little bit wider. I know, just giving you an answer. It's very hard to be precise, yeah, with the crayons.
There's so much.
After graphing, then, everything kind of fell into what we've been working on. You've got your graphing stuff, then after that we did simplify, verify, solve general, and then solve regular within a revolution. And to be honest with you guys, without giving you the problems that are on the test, I'm pretty sure we've done every single possible one that I could have ever thought of to work through. Okay? Simplify, verify. They're always going to be along the same complexity level of what you guys have had on all the quizzes. Things of that nature. That first worksheet that I gave you, remember how they were just god-awful, real scary bad ones towards the back there? Those are the real super complex ones. I hit you with the hard stuff first instead of just going easy on you. So next year I'll start easier on them and I'll hit them with the hard stuff at the end. So you're the guinea pigs. So good luck. Yes, sir.
On the test, are they going to be like as complex as the ones on the worksheet we got?
Like I said, it's going to be the same complexity of like all the past couple quizzes and stuff that you guys have.
Oh, okay.
Okay.
That's
Mr. West, okay, yeah.
So for the simplified and verified, it's usually going to be like sine of x plus cosine of x equals tangent or something like that, right?
Simplify, there's no equal sign. You have to figure out what they would say.
Cosine plus sine times cosine.
Yeah, it's going to be all the same styles.
That equals, and then verify
With the equal sign.
Yeah.
Remember, verify, you go from left, show what's on the left equals the right.
Yeah.
Yeah, like I said, we did that for a better part of over a week to go through. Yes, sir.
How many questions?
Total?
You said like
I think it's 11.
11?
I think it's 11
How many
questions.
points would?
1 billion. I moved it up from a million.
Oh my gosh, I was worried about million.
No, it's tough stuff to do. Yeah, I'll show you some problems that I would look at if I were you.
What's that third rule? Yeah, side squares of fucking
Shit, the rest of the year.
The third rule, remember, if you have sine squared
I wouldn't even come here.
plus cosine squared equals 1. If you remember that, you're golden. We are not. To find the other two, you do the following. Divide everything by sine squared. And that will generate 1 plus cotangent squared equals cosecant squared. Okay? If I generate, to get to the other one, if I divide everything by cosine squared, that generates tangent squared plus 1 is secant squared. From that, you can just manipulate the other to get the other pairs. Okay? So as long as you remember sine squared plus cosine squared, everything else falls into place. And notice, to get those other two, it only took 10 seconds to write it out. And that's what you and I are talking about. It's, if you know this one, which I know you do, it's very easy to plot that real fast on a piece of paper and go that. You guys all know your inverse functions. You know cosecant, inverse of sine, secant, inverse of cosine, and so on. That's the easy stuff. Just remember how to manipulate and how to create the other two of these via cosine squared plus sine squared. Jason.
I realized why I ended up like this.
I'm glad I was able to help you with that conversation.
Stretch his shoulder a bit.
Mine's a little steep.
Actually, mine really is.
I think we should all know where this is.
I don't know what I did.
It's a rough life being you.
Tell me about it.
What else?
Could you just do a couple of verify ones?
How are you done? Done so many of those. I'm trying to think of what else there is. Mr. May.
With general solutions,
Yeah.
when do you not do plus 2 pi?
Depending upon the problem. It depends upon the problem. What happens is when you're looking at general solution, one of the things you got to think of is when you have a general solution problem. Let's say you have a general solution and your answers are positive and you're looking at sine, it's going to wind up being pi over 6. All right, whatever. You have a positive sine value here at pi over 6. The other positive sine value is where? And that value is what? 5 pi over 6. Very good. So between these two values, there's not a constant value to get me from pi over 6, 5 pi over 6, back to pi over 6 every single time.
What? You asked me a question?
To go from pi over 6 to 5 pi over 6 is add half pi.
Right.
Okay. To go, or not half pi, add
And
two-thirds pi. Okay. To get from 5 pi over 6 back to here again, I'd have to add some different value.
Right.
So there's no constant numerical value that gets me from here to here and back. When that happens, and it's a general solution, you tack on 2 pi n.
Can you do
Okay.
one where you, and if it's tangent, isn't
Where you tack
plus
on
pi over 2?
A lot of times it happens with tangent.
Okay.
All right, or on anything on a 45. If it's a tangent problem, let's say you wind up with a tangent where you have a tangent of 60, the other positive tangent is down here.
you just do.
This is plus a pi to get here, and it's plus a pi to get back here. So then my answer would just be pi over 6 plus pi n.
And then when it's the plus or minus ones, it's just plus half pi, like pi over 6.
Careful, it won't work with this. At pi over 6, 5 pi over 6, it's not a constant value to get from here. You'd have to write out the 5 pi over 6 plus pi n as well, because that one gets you from here to here.
Okay, so it's
Okay.
never pi over 2.
The only time it could be a possible pi over 2, this is where a lot of you guys have had questions. The only time you're going to get a possible pi over 2 setup where it's is when you're at the pi over 4s. Because this forms right angles. Because remember at pi over 4 you create a square, so it's the same value. So the only time you wind up with that plus pi n is if you are on all 4 quadrants with reference angles of pi over 4. It's the only time that works. Okay. Yes, sir.
So if it's a general solution, if you're doing like sine and it's positive, you want to like put positive ones.
You're looking for all the positive ones, yes.
So you would only put the answer for the first quadrant, the second quadrant.
Yes, sir. Yep. Exactly right. Exactly right. If you're looking at for cosine, you'd be looking at them in first and fourth. In tangent, your first, third, and then you remember which ones are your negatives as well. That's why the whole idea of writing out and drawing up that reference angle, which you guys are really good at, comes into play. And remember which values are positive and negatives. Don't forget quadrantals. Yes, sir.
Generally, what is your first type of
My first one was at 10 years, and then I think the next one was 20. I haven't been to either one of them.
Why not?
Aren't you only like?
You've never been like Curious.
a couple towns away?
You know, to be honest with you, the friends that I have in high school that I'm still friends with, I still see on a regular basis.
I want to see all the other.
You know, there are times that I thought about, you know, every once in a while we have a bunch of guys get together, we all go play golf. We do that about once a year, and those are all the same guys we all hung out together in high school. So that's about. But now we all have kids and everything, so our kids know each other. So. But you don't really go out and see the other 200 people or 400 people. Because you guys have how many people in your class? Like 400? 600?
No, it's 400 sounds.
It's more like 400.
400? All right. So my graduating class was 213. So.
Our graduating class. I want to see how large. 8.
So here's some questions. Let me pause this for a second.